Annyeong Liam in for bear. GPU jobs are the primary workload on AICR. 4 GPU partitions, RTX-batch and rtx-devel for RTX PRO 6000 work, B200 batch and B200 devel for B200 work. The rule: use devel partitions for testing, switch to batch for production. Each node has 8 GPUs. Request as many as you need, from 1 to 8 on a single node. Or span nodes for distributed training. This video covers how to choose a GPU partition, how to write and submit a single GPU job, how to write and submit a multi-GPU job, how to verify GPU access inside a running job, and what to do when you hit out-of-memory errors. The partition choice comes first. It determines which GPU you get, and different GPUs have different memory capacities. Partition choice determines GPU type. RTX PRO 6000, 96 GB of GDDR7 memory, 8 per node, 19 nodes total, PCIe Gen 5. B200, 180 GB of HBM3E memory, 8 per node, 31 nodes total, NVLink 5, liquid-cooled. Use rtx-devel or B200 devel for testing. They have shorter queue times and a 4-hour wall time limit. Use rtx-batch or B200 batch for production runs up to 24 hours. Partitions are homogeneous. Every node in a partition has the same GPU type, so you don't need to specify GPU model in your script. Single GPU job on rtx-batch. Request 1 GPU with GPUs equals 1, 8 CPU, 32 GB of RAM, 8 hours. Load Miniforge 3 in CUDA. Run your training script. The partition is RTX-batch, so you get an RTX PRO 6000 with 96 GB of GPU memory. You do not need to specify the GPU model. Every node in RTX-batch has RTX PRO 6000. Multi-GPU job on B200 batch, 4 B200 GPUs on a single node. Use GPUs per node equals 4, 32 CPU, 128 GB of RAM, 12 hours. For PyTorch distributed training, use torchrun with nproc per node equal to the number of GPUs you requested. The 4 B200 GPUs on a single node are connected by NVLink 5. Giving very high GPU to GPU bandwidth, this matters for large distributed training workloads. Verify GPU access inside a running job. NVIDIA SMI shows GPU model, memory, utilization, and temperature. For PyTorch, import torch and call torch. CUDA is available, should return true. Torch, CUDA, device count tells you how many GPUs are visible. It should match what you requested. Torch, CUDA, get device name at index 0 gives the GPU model. If NVIDIA SMI shows no GPUs, check that you included GPUs in your job script and that you submitted to a GPU partition. Out-of-memory errors on GPU. 3 levers to pull in order. First, reduce batch size, the most direct reduction in GPU memory use. Second, enable mixed precision training with torch. AMP cuts memory roughly in half by computing in float 16 or bfloat 16. Third, gradient checkpointing trades compute time for memory by recomputing activations during the backward pass. Monitor GPU memory during an interactive session with NVIDIA SMI before scaling to a full batch job, so you can right-size your memory request. Your turn, paste this into Claude. I want to run a distributed LLM fine-tuning job on AICR using all 8 B200 GPUs on a single node. Write me the complete sbatch script with the correct partition, resource flags, and torchrun invocation for 8 GPUs. Then check, does it use B200 batch? Does it set GPUs per node equals 8? Does it call torchrun nproc per node equals 8? All 3 details together make this script correct. AICR GPU jobs, I'm Liam in for bear.